Danny.
So all these questions have been dealing with the performance, which on your title is only half of the story. So productivity.
Yes.
Tell us a little bit more about productivity. Why would programmers be more productive?
Well, okay, all right, good. So I'll give you the, and no, I did not pay Danny to ask me this question, but he does get a T-shirt. So good. So let me give you sort of the 3 or 4 top level items why this is the case. So we are working very much in what I will call the sort of Java view of the world, which is that there are a certain set of invariants about your language and your runtime that are going to be maintained by both the compiler and the runtime. And these invariants then make it so that as far as the programmer is concerned, certain class of errors you're never going to get into. And that's a big boost in productivity, as we have seen for a Java-like language. Now, in Java, there are significant issues that you cannot express functions at all well. There is this idiom for using inner classes and so on. It's really extremely cumbersome. We have direct support for closures for functions in X10 that dramatically simplifies the boilerplate code and the errors that you can make when you try to write in a functional style. Functional style is extremely important for concurrent computations. So there's a big emphasis on an X10 on being able to do what is in a standard fashion done in imperative concurrent programming by mutating shared variables. Do that in a functional style. To give you a simple example, is something called a collecting finish. You want to do map-reduce style computations in core, you need to be able to map your stuff out, you need to be able to collect it. Doing enqueries, you want to collect all the answers to your solutions. You typically do that in Java by saying, here is a variable, shared variable, anyone who finds an answer, add 1 to it atomically. Big source of race conditions, very easy to get wrong, really terrible, wrong way of doing it. In X10, we have a finish construct. In the collecting finish, you can simply offer 1. And these offers, the C of these offers going to that finish, are accumulated and reduced and you get an answer. Very applicative, very functional style of doing it. So we're really focused more on getting, my background is in theoretical computer science and functional logic programming languages, getting some of those idioms to work nicely in a concurrent object-oriented setting. I can go into more of these issues, but determinacy is a big deal for us. We don't have the support on it yet in 2.1, but it's coming in 2.1.1. But again, a number of kinds of idioms are simply taken care of by writing the determinate fragment. You'll never get into determinacy. Core language supports, as I said, deadlock-free code, another example of an invariant when things work out. Finally, let me just say, for the scale-out computations we're after, there is a significant interest in the machine learning community to look at X10, because today when they need to write efficient, compute-intensive codes, they have to do MPI, or they have to go look at MapReduce for doing that sort of stuff. The X10 places model lets you write code that runs on multiple places without getting into an MPI style of programming. That itself, I argue, is a big productivity boost. All right, thank you. Yes, please, go ahead.
Yeah, the question I have is that there's some researchers out near where I live who I know are supporting some high-energy physics applications.
Sorry, where do you live?
I'm sorry, yes. I'm sorry, what was that?
Where do you live?
Oh, I live out in the suburban Chicago area. There's some research lab out there.
Argonne National Lab, yes.
Mostly high-energy physics work.
Yes.
But they have some computing support for that.
Yes.
Where there's applications that are written in Fortran, that are
yes.
written in C, that are written in Java, a variety of different languages. And they really do want to try to go towards environments that are much more massively distributed
yes.
and a lot more performance benefits.
Yes.
How would X10 fit into that sort of a migration?
Yeah, so talking with folks whose primary code bases live in Fortran, live in MPI, the story about migrating to X10 is a somewhat complicated one, because we're not going to say, please rewrite all your code. There is significant work led by the Mark Sneer, the people at Illinois, around getting the so-called PGAS languages, and X10 is one of them, to play nicely in the MPI world, so that at least the new codes that those people are writing can be written in the PGAS style, and in particular make sure that the collectives interoperate well with MPI-based collectives. So really our focus with the HPC community is more around those people who simply cannot write the applications that they want to write in their current infrastructure. And these are typically dynamic, irregular, load balance kinds of things, not the standard dense physics kinds of computations. For them, the issue that Pascal raised about global load balancing and those things are much more important, very hard to do nicely in MPI. So those new kinds of applications are the ones that we are focusing on with X10 as far as the HPC guys are concerned. Thanks. Okay, more questions? All right, it is getting past our time, so I'll take a few more and then we'll stop. No, go ahead, last question.
Well, you
Okay.
You talk about running on JVMs,
Yes.
and one of the issues I've known about JVMs is that they don't support tail recursion all that well. Is that an issue?
All right, so JVMs don't support tail recursions. JVMs don't support languages with functions, and then JVMs don't support good generics. Doug, what can we do about this?
We're going to fix JVMs.
Yay, that's the answer. Thank you very much. Yes. All right, I think I'm going to stop on that high. Any other last questions from anyone? Thank you very much for coming. There are still some t-shirts, and I think we're out of food. If people want to get going for dinner and stuff like this, please get together and do what you want to do. Thank you again for coming.